hands that come up that talk about how important that is. Also, you guys have a distinct disadvantage in this class. There are 31 kids in this class. The class after this does significantly better than you. And I think that there are 3 reasons for that, 2 of which are related. The first reason is they only have like 21 or 22 kids in their class. With less kids, there's more time to pay attention to each need of each kid. That's important. Another one that's really important is that you guys come out of lunch, and they're not coming out of lunch. Anytime you get a kid coming out of lunch, it's a little harder to settle down. But then the third reason relates to it. They are much better at respecting the other kids' rights to learn, or their right to learn. You guys are not. You're very selfish. You don't hesitate to say to yourself, but I want to talk to this person. So you do it. Rather than think to yourself, you know, if I talk to this person, I could be distracting Mr. Lindquist, so maybe he's not going to teach as well. Or I could be distracting the person who overhears me. Or something somewhere happens in such a way that it frustrates people trying to learn. Now, I think the world is a much better place when people look at other people and say, you know what, let's take care of them first. Imagine if every person in this room, if their instinct was to say, let's take care of every other person, don't worry about me, I'll take care of every other person. What's really, really cool about that is you actually take care of yourself when you think like that. And I'll show you what I mean. Let's say that Diana's tempted to talk, and she says to herself, oh wait, I can't do that. Because Ava, Ashley, Anna, they need to concentrate, and if I talk, it's gonna mess them up, plus I might distract Mr. Lindquist. Well, she settles down, she doesn't talk, and these 3 learn better. But then one day, one of those 3 says, oh, wait a minute, I wanna talk to somebody else about something. Oh, but wait, I can't do that, because then I would distract Diana. So Diana winds up not being distracted. So in a sense, because Diana has respected the people around her, she's also respected and helped herself. These are the kind of lessons that you learn when you get a little bit older. And unfortunately, as I've said to you many, many times this year, decisions are just like muscles. You cannot, this is your bicep, this is your tricep. If you curl your bicep in, your tricep has to move also, your tricep stretches out. If I curl my tricep in, my bicep stretches out. It is impossible to move one muscle only. You must, as soon as you try to move one, others will move with it. So you need to make up your mind about the decisions you make in the classroom. It's impossible to make only one decision at a time. Unfortunately, in about a week, we're gonna end our market period. And, well, fortunate and unfortunately, there were some kids who did an amazing job on the test we took just the other day. One person got 100, one person got a 99, actually 2 people got 100. One person got a 99. There were kids who went from 25 to 80, from 37 to 75, and there were lots of kids who had grades around the 50 who turned in grades 75 to 80. So you could see the improvement. But if I looked at that list of names, I could have predicted it before the test. God bless you. I could have predicted it because I saw focus with them. I saw them very serious about their work leading up to the test, and I saw that they knew that they messed up when they got the bad grade on the first one. And it became very important to them to do better on the second one, which they did. But then there were some people who you could tell that they really weren't doing that much more work. And their grade might have went up a little bit, but it didn't go up too much. And I don't think we have any tests between now and the end of the market period. So your test grades are done. And we will have 1 or 2 more quizzes. So for the people who are really, really close, like if you have a 62 average or a 61, maybe this will get you up to a 65, maybe. But if you have a 61 average and you would have done better on the last test, you might have a 71 average right now, or 73 average. You might have done a whole lot better. but you're about to live with the consequences of your actions. Because of the decision that you made to not be as serious as you could be. There's gonna be a problem for some of you guys. And the only thing I can do is say that I hope you learn from it. And I hope you understand that when it's time to work, we come in, we settle, we have fun doing it. But that you make the decision that the learning comes first. The fun comes along for the ride, but the learning's very, very, very important. And if you do that, I think you'll find that your third marking period works out better than your second marking period. So, let's see, we got our lesson sheet, and we're starting this new chapter on functions. I think it's a fun chapter. I think it's like the most fun chapter of the year. So let's see how this goes. The volume of one cube is this. The volume of a second cube is that. How many times bigger is the first than the second? Well, I've said this so many times. When I get scientific notation numbers, I find them confusing. So let's just go by the first number. One cube is 9, the other cube is 3. How many times bigger is the first one? 3 times bigger. So, and isn't that because 9 divided by 3 is 3? So let's divide. Oh. Good. 9 times 10 to the 8th divided by 3 times 10 to the 6th. Divide coefficients, subtract exponents. So that's 3 times 10 to the 2nd. Well, you'll notice that none of the choices are in scientific notation. But which choice is equal to 3 times 10 to the 2nd? 300. 300, good. So choice C is right. Nice. Which of the following could be the graph? I didn't draw any graphs there, but it would look like this. You have to have a y-intercept of -3, so you have to touch down here, and a positive slope of up 2 over 1.
It would be B. That would be B.
Oh, you have them on your paper?
Yeah.
Okay, good. Which of the graphs could be x equals -3, x equals -3? Looks like that. X equals a constant number is a vertical line. It's a straight up and down line. Okay? Y equals a constant is horizontal, x equals a constant is vertical. They are opposite the axes. Watch. Isn't this the y-axis going up and down here?
Yeah.
So an x equals line is parallel to the y-axis. Okay? Which of the following pairs of coordinates can be the solution set of this system? I can just plug them in and see which one checks. I know A doesn't work because if I plug it in here, 0 does not equal 0 plus 4.
We don't have that.
Oh, you don't have that one?
We don't have that.
Okay. You should have this though. Turn to the next page. Okay? It's at the bottom. All right. Functions transform things. Functions change things. Right? And what they do is they change numbers. In a function, you get an input and you get an output. Now, there's a few different ways to understand functions, and we're going to come at these functions in every way imaginable. However, let's start with one of my best friends. I have great friends. I really do. You know, when I was in school, I didn't have a lot of friends in school, but I did have good friends. This kid Bobby Von Aiken was the best. He put up with a lot of problems from me, and he was a really good kid. His kid Johnny Riley and I used to get in fights all the time, but he was a good kid too. I cared about him. Didn't always treat him well, but he was a good kid. A bunch of friends that I had when I was in high school. There was a girl I was friends with who,
Lisa.
it was not a kid. Her name was Betty. She was a really, really good person, and she taught a lot. She taught me that there was actually more good in me than I ever thought there was. So, another kid, John Stelling, good kid. A lot of good kids, and I was really blessed to learn from them. So, here's one of my friends that we can learn from during the course of this year. This is my friend, Sticky the Stickman. Sticky is perfect. You know where Sticky lives?
The calculator.
In your calculator. He's the guy that does everything exactly right. He does things the perfect way. Now, let's show you how Sticky's liable to get to work here. Ready? Oh, I gotta go up a little bit higher. Hold on. Let me change the size of this. Can I do that? Yeah, I can do that. All right, so Sticky to Stick Man is a great way of figuring out what's going on here and how it's operating. And if you understand how things are operating on, then you understand how functions work. It's a great way to understand it. See, Sticky lives inside this function box, if you will, which is just like your calculator. And you tell Sticky what to do, and he does exactly what you tell him to do. Now, we have a function written on our paper. What does it say, y equals 2x minus 1? And it could also be said as f of x is 2x minus 1. These two things are exactly the same thing. Growing up, I had certain nicknames, which I will now share with you.
Wait, why?
Well, a few people called me Bobby when I was growing up. Link is definitely, a lot of my friends called me Link growing up.
Nicholas.
No, I never got called Nicholas. When I was little, well, not too little, but they used to call me, there was a cartoon on TV called Lancelot Link, Secret Chimp. And they used to call me Lancelot Link. That one, that kind of grew out of Link. Let's see, what else did they call me? One job I had, they called me Bobbery Bob.
Why?
Another job I had when I was a kid, that was at a butcher shop. That way they called me Bobbery Bob. And another one they called me was Linkwurst. Like a brand of bologna, bratwurst, or any of those things. So they called me Linkwurst. I guess I was bad, so the worst and Link. I guess that's kind of how that came together. Yeah, the evolution of my names, that's it. So, I got picked on with these names more often than not, but they were all the same thing. And I knew that when I went home, heck, my dad had more names for me than you can imagine. I walked through the front door, if Dad was having a good day, he'd go, Robert! Which is French for Robert, and I hate the name Robert.
Oh.
But he'd call me Bud, he'd call me Butch, call me Pal. You know what I called my dad? Pop. You know why I called him Pop? He said I wasn't allowed. I walked in the kitchen one day, and I said, hey Pop. He goes, don't call me that. I said, why?
You know about that?
He said, the day you call me Pop, I'm gonna knock you out. I said, Pop. He didn't knock me out. So, from that point forward, he was named Pop. All right? So anyway, little Linkwurst trivia right there. Yeah, I was a scutch when I was young. I was definitely a scutch. I was such a, as a quick aside, I don't want to waste too much time on this, but this is real important. This is more important than math. Anybody, please don't raise your hand because I'm not looking to embarrass you. Anybody here ever feel like their parents embarrassed them?
Yes.
And I'm not asking you to raise your hand.
All the time.
I'm not asking. My dad,
My mommy loves me.
My mother.
My mom is
my dad was raised by an alcoholic father, and family history is best I know it. My sisters know it better than I do, but best I know it, my dad's dad left home when he was like, I don't know, young, 7, 8 years old maybe. And I hear a story, I don't know how true it is, that my dad beat up his dad when my dad was like 16 and my grandfather came home drunk one day. But a lot of hard feelings and not a very good man, my grandfather, I mean. And my dad was a good man. And he did care, but I don't think he always knew how to show it. And I don't think he understood a lot of things about being a dad. Like, I met this guy down in Tennessee when we stayed down there for a week, and he said something to me that, on the one hand, made me really view life differently, and on the other hand, made me realize just how bad a dad I was at times. You know what he did that was really cool? I mean, really cool. He had an old pickup truck from the 1950s. And he walked up to each of his kids on the day they graduated high school. And he said, all right, tell me where you want to go. Pack a bag with a week's worth of clothes. And he said, just tell me where to point the car, we'll go wherever you want to go.
That's cool.
And they just spent a week going to places he always wanted to go to, wherever the kid wanted to go. If one kid wanted to go to the Basketball Hall of Fame, he went to the Basketball Hall of Fame. Another kid wanted to go watch a St. Louis Cardinals baseball game, they went to a St. Louis Cardinals baseball game. Another kid wanted to drive to Arizona and see the sunset in Arizona, he drove to Arizona. Whatever they wanted to do.
Oh, here.
What it really was a chance for the dad to bond with the kid. Well, my dad wasn't particularly good at that sort of stuff. What my dad was really good at was humiliating me. And, I just don't think he got how sensitive a kid can be. And, I remember, I was a little extra sensitive, because remember, one leg was shorter than the other, and I had all the surgeries and all this other kind of stuff. And I would constantly be picked on by other kids, and I put up a brave front, but by the same token, nobody likes being picked on. Nobody likes being put down. And one reason that I kinda like school is because I got everything right all the time. So it was one place where I could not be picked on. So my dad, he would always say embarrassing, humiliating things. Like, I can remember one time he said, I used to coach in the local Little League when I couldn't play sports because of my legs, and I was very young, I was like 13 or 14. And the local head of the Little League on opening day comes up to my dad, and she was president, she says, Bob, my dad's name was Bob too. She says, Bob, your kid is such a good kid. He's so polite, he's so respectful, he works so hard, he cares so much. He really is like a really super kid. And I remember my dad looked at her and said, is that my kid you're talking about?
Oh.
And I was like, I was furious. So one day I tell him I like this girl named Betty. And I said,
Lisa.
yeah, I said, I like Betty. Now, by this point in time, my legs had straightened out. I'd had my surgeries, I was looking good. I did a lot of weightlifting, I was very strong. And Betty was very popular, very pretty girl. And I asked her out and she said yes. So, not that I'm giving too many of the details of the love life here. One does not, actually, I treated her with a whole ton of respect, and if I was to have had a daughter, I would want a daughter I would want my daughter to date a guy who treated her the way I treated Betty, because I was always really, really good.
Sure.
No, that's God's honest. And you know what? I'll tell you what, I could bring her into this classroom today, and she would verify that.
Oh, could you?
So, well, she's in North Carolina, so it would be a little difficult, but if she came by, I could do that. So, anyway, my dad, he says to me, what are you doing on a Friday night? I said, I'm taking Betty out. He goes, who's Betty? So I said, it's a girl, I really like her a lot. I think she's great. He says, so where you going? I said, we're going to the movies. He says, where you going to the movies? I said, Sayville. I lived in Blue Point. I didn't drive. So I was a junior in high school. He says, well, how you get in the movie theater? I said, we're going to walk. He said, you cannot take a girl out on a date and walk to the movies. I said, yes, I can. He said, no, you can't. I said, oh, yes, I can. And I will make the money, and I will walk her to the movies. Now, the movie theater was about 4 miles from her house, 3 or 4 miles. He says, Bobby, you cannot ask a girl to walk 3 or 4 miles to the movie theater. He says, you might walk 3 or 4 miles, but you don't ask a girl to walk 3 or 4 miles.
Yeah,
Now, I couldn't figure this out, because I was who I was.
I ain't walking.
So my dad
See you later.
says, I'll drive you. I said, forget that. And he looked at me with complete shock on his face. He says, why would you say that? And I go, are you kidding me? I said, all you ever do is humiliate me. All you ever do is embarrass me. You never compliment me. You never say anything nice about me. And I'm not gonna let you talk to this girl that I really care about. Because if you do, you will insult me. And that could break up my whole relationship. So I don't want any part of this. So I'll walk. So I started thinking about it. I said, you really can't ask a girl to walk 4 miles. I can walk 4 miles.
I will.
I do it. I did it
No, I
yesterday.
won't.
I do it all
See
the
you
time.
later.
So I go back to my dad and I said, listen, is the offer still on the table to drive us there? He goes, absolutely. I said, can't say a word. He says, swear to you, I won't say a word. I said, just pick us up, say hello, drop us off. He says, okay. So he
What'd
drove
he
us to the
say?
movie theater that night. We saw Kramer versus Kramer, and had a good date. And my dad never said a word. And that was the day that my dad and I started to heal our relationship together. And it didn't heal overnight, but it got a whole lot better from that day forward. So it was a very, very, very good thing. Now, why in the world I related Sticky to Stickman to that, I have no idea. But I did. Now, y is equal to 2x minus 1. Oh, that's why. Because the way my dad said my name meant something more than appeared on the surface. See, if he said Robert, if he said Bud, if he said Bobby, if he said Butch, everything was going okay. If he said Robert Carl, no.
No.
If he said Robert Carl Lindquist Jr., the beatings were about to begin.
Oh.
Okay? If he started with taking the belt off when I was really young, he didn't do it when I was old. But when I was really young, he started taking the belt off going, boy, this is gonna hurt me a lot more than it's gonna hurt you. The first time he ever said that to me, I looked him right in the eye and said, bull. I was wise when I was a kid. So anyway, this doesn't say what you think it says, Davis. This doesn't say y equals 2x minus 1. I know it does, but it really doesn't. Just like when my dad said Robert Carl, that was more than just Robert Carl. This is more than y equals 2x minus 1. This means the output. Y is another word for output. Everybody say y means output.
Y means output.
X means input.
X means input.
The output is 2 times the input minus 1. So let's take a look at the table here. Let's fill in some values. 0, 1, 2, 3, 4, 5. Let's put those values in there.
We only have 4 spaces. The first space is X and Y.
Okay, oh, the first is X and Y? All right, so we'll go with X and Y, and then we'll go 1, 2, 3. So these are my inputs. X is input, so let's plug in a 1. What's 2 times 1? Guys, 2 times 1?
2.
2. Minus 1? 1. Good. Now let's plug in a 2. Each time I take the input, see, look, the input is X. Each time I plug in for X. Now I'm going to plug in a 2. What's 2 times 2? 4. Minus 1?
3.
Good. Let's plug in a 3. What's 2 times 3? 2 times 3? 6. Minus 1? 5. Let's plug in a 4. 2 times 4? 8. Minus 1? Good. Plug in a 5. 2 times 5? 10. Minus 1? 9. So the X's are 1, 2, 3, 4, 5. The Y's are 1, 3, 5, 7, 9. Now, one way to list it is as a table. Another way to list it is as a picture. And for the picture, I could go 1, 2, 3, 4, 5. And then over here, I could do 1, 3, 5, 7, 9. And I draw a little arrow. And can you see that there's the sense through this picture that the numbers are changing? They are transforming, like the movie Transformers, where you get Maximus Primus or Primus or whatever the name of that guy is. Whatever, yeah, him. And he turns around and he becomes a car into like this really big destructive animal. Okay? Now, there's another way to represent a function. This way you've been doing it all year long. Oh, I didn't want to do that. Oh well, I can remember what it is. Here is as a set of ordered pairs. Guys, look over at your table for a minute. And remember, any coordinate on a graph is always x, y. So over here, we have the coordinate 1, 3, 2, 5, 3, 7, 4, 9. Wait.
4, 7, and 5.
Wait, it was 1, 1, right? Yeah, it was 1, 1, 2, 3, 3, 5, 4, 7, 5, 9. And I just make them into ordered pairs. So I go on my graph, and I go, here's 1, 1. The next one I do is 2, 3. Then I do 3, 5. Then I do 4, 7. And 5, 9 would be up here. It really can't fit. And I graph it, and hey, what did I just make? I just made a line, right? Didn't we just graph a bunch of those? Hey, what would the equation of this line be? Y equals what? What's the y-intercept? It really goes through here. Negative 1. And what's the slope? Guys, what's the slope? Come on. Up 2 over 1. So y equals 2x minus 1. Wasn't that the name of the function?
Yeah.
So we've actually been doing functions all along. We just haven't technically classified them as functions. But they are functions nonetheless. Okay? Does that make sense? Okay. Now you're going to do the same things we just did at your seat. Here's the name of the function. F of x, or y equals 3x minus 4. Here's Sticky to Stickman. I want you to do a table with 1, 2, 3, 4, 5. I want you to draw it as a picture and then graph it as a set of ordered pairs. Go ahead. Mikey? Put your foot down. Get that table filled in.
There's no graph.
There's no graph.
Yeah, there is.
There's not.
Oh, wait, I'm on.
Looks like there's a graph underneath it.
No, I'm on.
No, go back.
Oh, I need.
No, I think the graph is right. That's weird. Oh, it's on the next page. Yeah, turn it over on the next page, you'll see the graph. It must have been fit on the first page. Okay, another minute or so.
What about your sister?
What's that?
You don't know the graph. You already have the coordinates.
Okay. So let's fill in the table now. Ready? Excuse me. Head in the game. X, Y. 1, 2, 3, 4, 5. And let's plug each of these into our rule. Now this time, I know the rule says f of x equals 3x minus 4. I know you can read it y equals 3x minus 4. But just like Robert Carl meant, I'm
You're in
doing
trouble.
something wrong. I need to listen up here, or pain follows. Just like that. When I say y equals 3x minus 4, what I'm really saying to you is the output, call it f of x or y, it's the same thing. The output is 3 times the input minus 4. So here's my table, and the x column is a list of inputs that we're going to do one after another, after another, after another. So let's plug in a 1 now. What's 3 times 1? 3 minus 4, negative 1. Good. Now let's plug in a 2. What's 3 times 2? 6. Minus 4, 2. Very good. Let's plug in a 3. 3 times 3? 9. Minus 4, 5. Good. Can you, perfect, excellent, thank you. Next, let's plug in a 4. 3 times 4? 12. Minus 4, 8. Excellent. And now let's plug in a 5. 3 times 5? Minus 4? 11. Hey, by the way, I just want to note something here, and we'll talk more about it in the coming days. What is this column going up by? 3.
3.
What was the slope?
3.
Do you think that's a coincidence?
No.
No. Or as my sister Sandy would say, a coinky dink?
Oh,
Not a
my
chance.
sister said all the time. Didn't you
Not a
point to the
chance.
face?
Okay.
Yeah.
Now, as a picture, picture looks like this. Ready? 1, 2, 3, 4, 5. Negative 1, 2, 5,
Yeah, didn't you
8,
point to the
11.
face? You should ask them if that's sister.
Ava? Okay, so we have our picture drawing. How are you looking so far? You good on this on your paper?
Yeah.
Okay, and the next part is to graph it, and the graph would look like this.
It's on the next page.
And then if you were to look at this equation as a graph of a linear function, which we talked about before, we would say it's y equals, the slope is up 3 over 1, up 3 over 1, so that means 3x, and the y-intercept is negative 4. And sure enough, that was the function rule, Davis, that we just had to follow a couple of minutes ago when we created our function. Okay? One last thing I want to mention before we leave today. Hey, again. One last thing I want to mention. When we draw a function, and we draw it as a picture, okay? And then we do all these guys over here. The guys on the left where the x's go, this is called the domain. and where the Ys go, it's called the range. And then tomorrow we will pick up at that particular point in time, okay? Finish the package. Business as usual. No, I definitely don't think it's a hard unit. I think it's a fun unit, to be honest with you.
Oh, I thought that said Johnny.
The water bottle. Right there.